Okay, so let me go ahead and share my screen just to show you guys what's in Schoology and what we're going to be working on today. So today, okay, so if you click on the folder for today, you're going to see these three items in Schoology. So what we're going to do, right here where it says forces acting in 2 dimensions, this is what we're going to focus on today. So there is a total of 6 of these problems. We're going to do the so there's 6 problems, A through F. We're going to do A and B as a class, and then you guys are going to do C, D, E, and F by yourselves. Okay. And as soon as you guys get done with that, you're going to take a picture of it and you're going to upload it here to the submission box right here. So you're going to submit it here. And of course, I put some, since we're going to be going over a lot of mathematical steps today, I've actually put notes in Schoology for you guys. So if you click on this right here where it says notes, steps to finding the net force, these notes here will pretty much summarize all the steps that I take today. Okay. So again, since we're doing a lot of mathematical steps today, I wanted to kind of just, chop everything up and put it in steps. And I put those notes in Schoology for you guys. Okay. All right. So now, before we begin, let me show you guys this PowerPoint first. Okay, let me close this. Okay, so I want to begin by just explaining conceptually what's going on here on today. Okay, so everybody in here knows that if you have an object and you have some force acting on that object will accelerate. And we know that, basically, we know that according to Newton's second law. So we all know that Newton's second law says that the sum of the forces acting on an object is equal to mass times acceleration of the object. We've already talked about this. If I rearrange this equation here and I solve for acceleration, basically acceleration is the sum of my forces divided by my object's mass. Okay. So, and again, this was something we've already gone over. This is Newton's second law. Everybody in here should be familiar with it. That if I know my object's mass, if I know the net force or the sum of the forces acting on the object, I can mathematically calculate the acceleration in meters per second squared. Okay, and we can kind of visualize acceleration by using an example here. Imagine here that I have a box here, and imagine that I have a single force here acting on this box. Okay. Now, guys, in our situations before, we were dealing with forces that were acting in 1 dimension. In other words, the force was either acting solely in the vertical direction or it was acting solely in the x direction. Okay, so we were dealing with 1-dimensional forces before, where we have forces acting in y or forces acting in x. But guys, what would you do if you have a situation like this where you have a force acting diagonally? Okay, where your force acting diagonally. Okay. How would we do this? If we knew the magnitude of this force here and we knew the mass of this box here, how could we calculate the acceleration of this object here? That is what's going to be our focus on today. Okay. Now, now it should be obvious to you all that if I have an object like this, I have a box, and if I'm pulling at this box like this, if I pull and pull hard enough, eventually this box will accelerate like this. The box will accelerate in this direction because notice what's happening here. Notice I'm pulling in both the x direction and the y direction at the same time. So notice as I pull, notice we can treat force as if it is a vector. So notice this force, if I split it up into its x and y components, notice this force is pulling in both the x direction as well as the y direction at the exact same time. So if I pull hard enough, it should be obvious to you guys that the box is going to accelerate like that. Okay, does that make sense? It's going to accelerate like this because I'm pulling in both directions simultaneously. What about a situation like this, guys? What if I have a box like this, and what if I'm pulling at it in this direction here? Okay, so guys, whenever you're analyzing these situations, you want to look very closely at the direction of your arrows. So if you notice here, this box here, the force is acting on this box. If you notice, this force right here is pulling to the left, and it's also pulling down. So it's pulling in both those directions simultaneously. The force is acting diagonally. So guys, it should be obvious to you all that if I pull on this box hard enough and pull on it hard enough, eventually this box is going to accelerate. It's going to accelerate because I'm pulling in the x direction while at the same time I'm pulling in the y direction. Okay, so guys, in these situations right here, we're going to be analyzing force vectors by basically splitting them up into their x and y components. Okay, so just to give you guys an idea how this will look like, again, if I pull hard enough on this box here, if I pull hard enough, eventually this box is going to accelerate like this. Right, now see that it's going to accelerate down and to the left. Okay, and I can actually figure out the magnitude of the acceleration, assuming I knew the mass of the box and the magnitude of the force acting on the box. So that's what's going to be our focus for today. Okay, analyzing these situations where we have forces acting on our object and our forces are acting diagonally. Okay. So let's go back to Schoology, okay, and kind of pull up these assignments here. So let me open up this file in Kami. If this file will come up. Okay, so the title of this assignment is Forces Acting in Two Dimensions, right? So we have forces that act in both x and y simultaneously. Let me pull up the steps for analyzing these problems. That way you guys are clear on what's going on here. All right, guys, I'm just pulling up enough files so that I can write on everything. Okay, so guys, let us read the instructions. And remember, I'm going to do letters A and letter B with you all, and then you guys are going to do C, D, E, and F. Okay. So the directions say the 6 figures below represents treasure chests with 2 forces acting on them. We are looking down on the treasure chest from above. The length of the force vectors represent the magnitude of the forces. All of the chests have the same mass of 5 kilograms. Did y'all get that? So all of these treasure chests have a mass of 5 kilograms. Calculate the magnitude of the acceleration of each treasure chest below. Show your work for full credit. Okay. So guys, what we want to know, we want to figure out what is the magnitude of the acceleration of each treasure chest. That's the goal here. And so obviously one of the main equations that we're going to use, or the main equation I should say that we're going to use, is Newton's second law that says that the sum of all of my forces divided by my object's mass is equivalent to my acceleration. Okay, so that's the equation we're going to use. Now, so let's start off with situation A. Remember, the instructions said that all of the treasure chests have a mass of 5 kilograms. Okay? So that treasure chest there has a mass of 5 kilograms. Okay. Now, if we want to know the acceleration of treasure chest A, basically just the sum of the forces divided by the mass would give me acceleration. However, but guys, look at these forces here. Okay. Notice this situation is slightly more complicated compared to the free body diagrams that we worked on in the past. Notice that we have forces acting diagonally. Okay. Notice I have a 10 Newton force pulling in this direction, and I have a 6 Newton force pulling in that direction. So we're going to have to use some vector analysis and some trigonometry to solve for the magnitude of the acceleration of this treasure chest. Okay, so that's what we're going to have to do. In order to do that, guys, this is where the 3 steps come in. Okay, so guys, before you can even begin calculating acceleration, you need to solve for the sum of the forces first. Okay. So guys, I've given you guys 3 steps for how to solve for the sum of the forces. Okay. That's these 3 steps right here. Okay. Step 1 says to split up each vector into its x and y components. Be sure to put the correct sign for the indicated direction. Step 2 says combine the x components together, then combine the y components together to obtain a single vector. And lastly, step 3 says find the magnitude of the resultant vector. Okay, so guys, using these 3 steps, we're going to solve for the sum of the forces acting on treasure chest A. Okay. So guys, starting off, we're looking at treasure chest A. So we're doing this by itself. Okay. First. Okay, so guys, before I begin doing the steps, let me draw out what's happening here. So notice, guys, I have 2 forces acting on my treasure chest. I have one force that's acting like this in this direction. And guys, if you guys notice, that is a 10 Newton force. So this force here is clearly 10 newtons. So that's a 10 Newton force right there. And I also have another force acting on this treasure chest. This force is acting right here, and then this is a 6 Newton force. Okay, so let me zoom in. So this right here, this is a 6 Newton force. Okay. Hopefully everybody's following me so far. So so using those 2 forces, guys, basically, guys, we're going to need to add up these force vectors right here, add up both of them so that we can get the net force of the overall force acting on the treasure chest. So again, imagine both, these are forces pulling on this chest. Okay. So in order to do that, guys, here's where we start. Let us look at step 1. Step 1, and then again, this is how we find the net force acting on each object. So we're dealing with situation A. Step 1 says split up each vector into its x and y components. Okay. So let's start with this right here, this first vector right here. So notice how, guys, notice this vector right here is pulling, notice it's pulling in the x direction, okay, at the exact same time that is pulling in the y direction. Okay. Can everybody see it there? Okay. So it's pulling in the x direction at the exact same time that it's pulling in the y direction. Okay. So This is what I mean when I say split up each vector into its x and y components. So this is the first step. And remember, guys, this angle right here, this angle is 60 degrees. Okay, I see that. So that angle right here is 60 degrees. So we want to take this vector here. We want to split it up into its x and y components. And we also want to take this vector right here, and we also want to split this vector up into its x and y components. So notice how this vector has an x component. Okay. And this vector here also has a y component, like this. Okay. And we all should be able to see right here that this angle here is 30 degrees. Okay. All right. So guys, we're still on step one. We're splitting these vectors up into its x and y components. So this has an x component, and then this has a y component. Okay. Okay. So guys, we're on situation A. Now remember, guys, in order to split these up into its x and y components, we need to use trigonometry. In other words, we're using SOHCAHTOA. Okay. So guys, let us first begin by looking for this x component here. Can someone tell me, in order to find the x component to my vector, am I going to use sine or cosine? What do y'all think? Sine or cosine? Notice, guys, that's the adjacent side.
And hypotenuse?
Yeah, so this is the adjacent side. 10 is my hypotenuse. 10 newtons is my hypotenuse. That's the length of this vector here. So that means, am I going to use sine or cosine to solve for x?
Is that sine?
No, so you use sine for the opposite side.
That's cosine.
It's cosine, exactly. Remember, you always use cosine to solving for the adjacent side. Whenever the adjacent side is related to the hypotenuse, you're going to use cosine. Okay, so I'm gonna write this down. But yeah, thank you, Angelina. So so for situation A, okay, so to solve for my x component, guys, basically I need to type in cosine of 60 degrees in my calculator, right? So for my x component, cosine of 60 degrees is equal to my adjacent side, which is x, over my hypotenuse, which is, guys, notice what my hypotenuse is. This is 10 newtons. And again, guys, you want to write down what I'm writing down, because again, I want you guys to show your work. Yes, Angelina, this is the part where you're writing down. Yeah, because I'm officially beginning step one. Because we're splitting up each vector into its x and y components. Now, Jeremiah, in order to solve for y, am I going to use cosine or sine?
Solving for y?
Yeah. Notice this side is opposite my angle.
So that's going to be sine.
Exactly. So to solve for y, you're going to do sine of 60 degrees is equal to my opposite side, which is y, divided by my hypotenuse, which is 10 newtons. So my hypotenuse here is 10 newtons. Okay. Now here's what I need for you guys to do. I need for you guys to take out your calculators and someone solve for me the magnitude of the x component and the magnitude of the y component. Could y'all do that for me?
Wait, are these problems, is this problem you're doing on a worksheet?
Yes, I'm doing A right now. I'm literally doing situation A. I'm going through all the steps of finding situation A. Yeah. Remember, our ultimate goal is to solve for the acceleration. And again, we're basically, Jeremiah, we're still under step one. Yeah, step one is to split up each vector into their x and y components. Okay, can someone tell me what you guys get from when you solve for x and what you guys get when you solve for y? Okay, so Stephanie, you said the x component is 5, and then what is the y component? Okay, yeah, that's right, Stephanie. What is the y component? Again, y'all should know how to solve these equations for x and y. No, it's not about 1. Okay, put 10 times sine of 60 degrees in your calculator. Right, if you in order to solve this equation for y, you have to multiply both sides by 10. Okay, yeah, that sounds more reasonable. Yeah, I'm going to put 8.66, which is what I got on my answer key. Yeah, so okay, so guys, whenever we solve for x here, our x component here was 5 newtons. So 5 was equal to x. Okay. And whenever we solve for our y component, we got 8.66 newtons is equal to y. Okay. So so that's our x and y components for that first vector. Okay, so guys, so for this vector here, the x component is 5. X component is 5, and the y component was 8.66. Now, guys,
So there's going to be two. My bad.
I'm sorry.
There's going to be 2 answers for A.
We haven't even got the answer yet. I'm still in step 1. That's
Okay.
a lot of math here. I'm gonna circle the answer. So okay, so guys, look closely at the direction. So guys, look at where the x arrow is pointed. That x arrow is pointed to the right, and look carefully where the y component is pointed up. Okay. So that means if one is pointed to the right and one is pointed up, that means both of these are going to be positive. So I'm going to have a positive 5 for x. I'm going to have a positive 5 for x. I'm going to have a positive 8.66 for y. Hey, guys, your sign matters. And y'all see in a minute why your sign matters. Okay. Again, guys, we are still in step 1. Again, we're still working on step 1. Now, okay. We're not done, though, with step 1, guys, because step 1 says to split up both vectors into their x and y components. Okay. So, guys, look at this vector right here. So, this vector right here, we want to split this up into its x and y components. So, this vector right here has an x component, and this vector also has a y component. Okay. So, okay, guys, let's solve for this x and y component here. Again, we're still in step 1. So for our second vector, notice we're using, for cosine, we're going to use cosine to solve for x, right? Because cosine of 30 degrees is equal to adjacent over hypotenuse. Okay, so cosine of 30 degrees is equal to my adjacent side, which is x, over my hypotenuse, which is 6. Okay. Okay, guys, now that I set up the equation to solve for x, okay, what I want to do now I want to solve for y. So for y, I'm going to use sine, right? Because this is my opposite side. This is the side the opposite of my angle. So I'm going to use sine. Basically, I'm going to use sine of 30 degrees is equal to y divided by 6, right? So sine of 30 degrees is equal to y divided by 6. Could someone put those values in their calculator to tell me what x is and tell me what y is? Y'all should know how to solve for x and y. This is just algebra. Y'all should know how to solve for x and y. So yeah, yes, Stephanie, you're right. Stephanie, could you put that in the main chat box? For x and y, guys? Yeah, so, okay, so that is the y value. What did y'all get for the x value? So y'all both, yes, Stephanie, yes, Anthony, you guys are right whenever you're solving for y, right? Because you remember you multiply both sides of the equation by 6 to get x and get y. Anyone want to tell me what you guys get for x? Yeah, so that is right. I'm gonna write what I have on my answer key is 5.19, which you're right. It rounds to 5.2, which is close enough. So my x value here is 5.19, and my y value is 3. And again, these are not the final answers. These are just the x and y components. Just showing you guys what the x and y components are. Okay. And again, guys, we're still in step 1. Okay. So, guys, this vector right here has an x component of 5.19. Okay. Now, guys, let me ask you a question. Remember, your direction matters. Guys, look at that arrow. Where's that arrow pointed in the x direction? It's pointed where? To the right.
Right.
Yeah. So is that positive or negative?
It's positive.
Exactly. Guys, your direction matters whenever you guys are working out these problems. So it's a positive 5.19 for the x component. Okay, so it's a positive 5.19. But guys, look at this arrow in blue. You guys clearly see not only is it pulling to the right, it's also pulling down. So it should be obvious to you all that this y component here is pulling down. Okay, so if it's pulling down, is that a negative or positive y value? Anyone?
It's negative.
It is negative, exactly. So that's going to be a -3. Yeah, guys, it's very important that you guys get your negative and y values down. Okay. All right, guys, we're not done. We're not done. I mean, I told you guys that we're going to be doing a little bit of math today. Remember, we're still on step 1. Step 1 says was to split up these vectors into x and y components. We just did that. Okay, guys. So, guys, this vector right here, if I split it up into its x and y components, this is what I get. If I take this vector right here, split it up into its x and y components, this is what I get. So now that we've done step 1, okay, let us move on to step 2. Okay. Notice what step 2 says. Combine, yes, Aaron. Combine the x components together, then combine the y components together to obtain a single vector. Aaron, when you're doing it by yourself, it's not. It doesn't take that. It doesn't take. It doesn't take. It's not going to be that hard when you take it by yourself. It's just that because I'm trying to explain each step, it's going to take a while. But once you get the hang of it, Aaron, you can finish this in like 20 minutes. It's not going to be too bad. I know, Jeremiah, we've been doing math for the last 2 weeks, but this is we're literally doing all the math in the past 2 weeks in one problem. Where am I? Okay. Oh, okay, guys. Going back to step 2. Step 2 says combine the x components together, then combine the y components together to obtain a single vector. Okay. So guys, step 2. So I'm gonna write out step 2. Okay, so guys, remember step 2 says to combine our x and y components. Okay. So guys, can someone tell me if you add up those x components there, what do you get? Can someone tell me?
You will get 4x 10.19, and then for y you would get 5.66.
Thank you. And that's all you have to do for step 2. Y'all got that? Did y'all see what Stephanie did? She just combined the x components to get that, and then combined the y components to get that. Now, guys, the third and final step for finding the net force acting on the object says find the magnitude of the resultant vector. Okay, so guys, here is our resultant vector. It's positive 10, 1.9, and then positive 5.66. Okay, so step 3 says find the magnitude of that vector.
Wait. Where y'all get that whatchamacallit from again? Y'all did y'all add something together?
Yeah,
Yes.
basically just added the x and y values from that we got in step 1.
Okay, so it's going to be -3.
Yep.
Yeah.
Do you know why?
Is that the only minus?
Do you know why it's minus? Look at this y arrow. Where's the y arrow pointed?
The y is going down,
The
so
y
it's
is pointed
negative.
down. Yeah, that's why that's negative. Yeah.
Oh, okay, that makes sense.
Yeah.
10.
And so Jeremiah, it's very important that you look at the direction of your arrows. Since that blue arrow, since it's pointed to the right and also pointed down, you know the y value is going to be pointed down. So therefore it's going to be negative. But everything else is positive. Does that make sense?
Yeah.
Okay. All right, guys. Lastly, step 3. Step 3 says find the magnitude of the resultant vector. Okay. So find the magnitude of the resultant vector. So guys, y'all tell me, we talked about this last week. Anytime I have a vector, how do I find the magnitude of that vector? In step 3, how do we find the magnitude? What do we use to find the magnitude of a vector? Anyone? Pythagorean theorem. Thank you, Stephanie. Pythagorean theorem. So it's going to be a squared plus b squared equals c squared. So and guys, once we do that, we're going to have our overall magnitude. So let's just plug everything in. So A is 10.19 squared plus B, which is 5.66 squared. All of that is equal to C squared. Everybody in here should know how to solve that equation for C. I shouldn't have to go through the math, the algebra. Y'all should know how to get C by itself. It's basically the square root of everything on your left side. Anybody want to tell me what you get? Um, um, Angelina, you can. I round everything. I think in my key I just round everything to the second decimal place, but um, I don't. It doesn't matter to me if you do to the tens place or the hundreds place. As long as it's close enough to the right answer, you should be good. But I'm just doing everything to the second decimal. Yeah. So Stephanie, you're right. Um, on my answer key, I put 11.66. Is that okay, Stephanie? I'm just gonna write what I have on my key. But you're right. If you want to write 11.7, that's fine. Believe me, that's close enough. Hmm. Well, let me see. Yeah, so 11.66 squared. Okay, so hopefully everybody's following me so far. We just did the 3 steps for how to find the net force. Okay. So we got 11.66 newtons. Okay. Okay, so guys, but we're not done. We're not done with situation. We're almost done with situation A. We're almost done. Okay. So guys, hopefully it should be obvious to you all that when I take this vector right here and I combine it with this vector right here, I'm going to get a net force. I'm going to get a net force that is. Hold on. Ooh, that's too big. I'm going to get a net force that is 11.66 newtons because we just calculated that. Jeremiah, that's fine. It's so close. I'm not gonna take up any points for that. So 11.66 newtons. But guys, someone tell me what is the last thing we need to do on situation A? If we know that the net force is 11.66 newtons, we know the mass of the treasure chest is 5 kilograms. How can we calculate the acceleration? Anyone?
Divide by mass.
Yep. And then when y'all do that, what do y'all get?
So it's going to be 11.65 over 5.
Mm-hmm.
I got 2.33.
Yes, sir. And yes, ma'am. And Stephanie. Guys, please don't forget to put your units for acceleration. Acceleration is in meters per second squared. Okay. Okay, guys, now that is the answer for A. Guys, I know that seemed like we did a lot, but it wasn't. It wasn't as, I promise, it wasn't as bad as it or as long as it seemed. I was just kind of going through everything slowly because I wanted to be sure that you guys understood all the steps. When we go through B is probably going to go a little bit faster because now that you guys got the steps down. But that's your answer for situation A. Is 2.33 meters per second squared.
So how many questions are on the assignment?
It's just 6 questions. We're gonna do so. There's A, B, C, D, E, and F. Jeremiah. We're about to do letter B, and then once we do letter B, you're just left to do these 4, which that should take you like 20 minutes. To do
Are
like
you
5.
sure you don't want to stretch it out to see, just for gratitude?
No, I'm pretty sure.
Oh man.
All right, guys. Can I do B now? Are we good? Angelina, I see you still writing. Are you good?
Oh yes, I'm good. I'm
All
sorry.
right. No, you're good. You're good. I'm just making sure that everybody's ready before I move on. All right. I'm gonna do. Let's move to situation B.
filled up half my page.
Yeah, hey, I did tell y'all we're gonna be doing a lot of math today.
I think I have almost like a whole page. So.
Really?
But I love spaces. So.
I mean, if y'all need to take a picture of 4 pages and upload it, that's fine too. I mean, I'm just going to have to go through everything. Okay, guys, let us look at situation B. Let's look at situation B. Okay, now guys, in situation B, okay, we have 2 forces acting on the treasure chest. Notice we have a 10 Newton force pulling this way, and we have a 6 Newton force pulling that way. And remember what our goal is, guys. Our goal is to solve for the magnitude of the acceleration in situation B. Okay, so our goal is to solve for the magnitude of the acceleration. Okay. So that's what we're looking for, the magnitude of the acceleration. Okay. So remember, guys, before we can solve for acceleration, we need to solve for net force first. So net force divided by the mass gives me acceleration. Oh, and guys, don't forget, this is also 5 kilograms as well. So all the treasure chests are 5 kilograms. Okay. So now, in situation B, okay, remember, in order to solve for the net force, this is where you're going to use these 3 steps. These 3 steps will help you solve for the net force acting on your object. Step 1, split up each vector into its x and y components. Step 2, combine the x components together, then combine the y components together to obtain a single vector. Step 3, find the magnitude of the resultant vector. Okay, so let's do these 3 steps first to find our net force. Okay, so guys, look closely here. Okay, so for step 1, notice I have a 10 Newton force pulling that way. So I have a 10 Newton force pulling in this. I'm sorry, guys. Hold on. I'm trying to write this right. There we go. Okay. So I have a 10 Newton force pulling that way. Okay, that's better. Okay. So clearly this magnitude here is 10 newtons. Okay. And notice, guys, I also have a 6 Newton force pulling that way. Okay. And the magnitude of this force here is 6 newtons, right? And again, I'm putting newtons there because we're dealing with the force. All right, so guys, let us start with step 1. Step 1 says split up each force into its x and y components. So step 1. Step 1, split up each force into its x and y components. Okay. Again, we're on situation B. Okay, so guys, remember, whenever you're splitting a vector up into its x and y components, you want to look very closely at the direction. Notice this vector, not only is it pulling toward the left, it's also pulling up at the exact same time. Okay. So clearly we have an x component, and also we have a y component. Okay. And everybody should be able to see that that angle there is 45 degrees. Okay. Now, guys, in order to solve for x, am I going to use sine or cosine? Notice that x is adjacent to my angle, 45 degrees.
Cosine.
Cosine, yep. So I'm going to say cosine of 45 degrees is equal to my adjacent side, which I'm going to call x. All of that divided by my hypotenuse. My hypotenuse is 10 newtons. Okay. Which means, Jeremiah, if I'm using cosine for x, obviously I use what for y?
Sine.
Sine, yes, because this is opposite my 45-degree angle. So remember, sine of 45 degrees is equal to my opposite side, which is y, divided by my hypotenuse, which is 10. Y'all follow me so far?
Yeah.
Can someone put in their calculator and tell me what you get for x and y? Yes, that is correct, Stephanie. So x is equal to 7.07. And what did you get for y?
The same thing.
Yep. Yeah, guys, anytime you have a 45-degree angle, your x and y's will always be equal for 45 degrees. That's true for a 45-degree angle. And you have a right triangle. Both x and y 7.07. All right, is everybody following me so far?
Yes.
Okay, awesome. Okay, now guys, we're not done though. So look at these arrows, guys. Guys, look very closely at the directions. So now notice this 10 Newton force is pulling up and to the left at the same time. So the x component is pulling toward the left, but the y component is pulling up. So guys, if my x component is pulling toward the left, is that a negative or a positive value?
Negative.
It's negative, yeah. Yes, so it's negative 7.07 for x. Okay. What about my y component, guys? My y component, so is that if that's pulling up, is that negative or positive? So it should, guys, it should be obvious to you all what that is. If it's acting upward, that's positive. Okay. Yeah, thank you, Angelina. Positive. Yeah. 7.07 newtons. Okay. So everybody follow me so far. So this 10 Newton force, if we were to split it up into its x and y components, it would be a negative 7.07 and then positive 7.07. Okay. So guys, we're still in step one. Now that we've taken this vector and we split it up to its x and y components, we can easily do the same thing for this right here. If I take this vector here, if I was to split it up into its x and y components, this is actually pretty easy, guys. Notice I don't have to use any trig here. Notice the x component is a positive 6 newtons, right? Because it's acting toward the right. But guys, is there a y component here on this force? Is there any y component?
No.
No. So the y component is just 0. So guys, whenever you write this vector out into its x and y component, just 6, 0. It's really that.
Wait, what am I missing? Wait, did you do the other, whatchamacallit yet?
What do you mean?
The other, the 6 and?
That's what I'm doing now.
Oh, so you got the 7.07 from the first one?
Yes, for this vector. For the 10 newtons, yes.
Whoa. All right.
Yeah. All I did.
Wait. So did you so that means you already did what you gonna call it?
What do you mean?
Wait. Oh, you didn't do it yet.
Oh, are you talking about trigonometry, SOHCAHTOA?
Yeah, you
I don't,
did the cosine and sine
Jeremiah. I
for.
don't have. Yeah, I don't have to use cosine and sine for this arrow here because notice it's not pointing at an angle.
Oh.
Yeah. So the x component is 6, but the y component is just 0. You only need to use trig whenever it's pointing at an angle. But if it's not pointing at an angle, you just write down the x component, write down the y component, because you can just look at it and see. Yeah.
Okay. Yeah, I was confused. I thought I missed out on something.
No, you're good. You're good. Okay, so guys, that's step 1. Remember, we're still trying to find the net force. Step 2 says combine the x components together, then combine the y components together to obtain a single vector. Okay. So for step 2, we want to add up our x components, find up our y components. Can someone tell me when you add up this vector to this vector, right? Because we want to add up those forces to get the sum of the forces. When we add up the x components and up the y components, what do we get? We're basically combining x's and y's.
You got to combine
Negative.
the x and the y's.
You get what?
Is that 1.7? No, that's wrong. Minus 1.07.
Yep, minus 1.07. And then the y component?
It's just 7.07. Positive.
Yes, sir. Okay. Follow me so far? That's step 2. Okay, so guys, all I did was I took this vector here, I combined it with that vector. Now, what about step 3? Step 3 says, once we add up those vectors to get our resultant vector, step 3 says find the magnitude of the resultant vector. How do we find the magnitude of resultant vectors? We just use, y'all know this, Pythagorean theorem. So guys, for step 3, we would just use Pythagorean theorem. A squared plus b squared equals c squared. Now guys, technically, even though this is a negative 1.07 squared plus 7.0 squared, let me ask you guys a question. If you guys take a negative and you square it, in other words, a negative times a negative, what is that? A negative times a negative gives you a what? A
Positive number.
positive, yeah. So technically, since a negative times a negative gives you a positive number, whenever you're using Pythagorean theorem, basically you just have to worry about just putting a positive number there, and you should be good. Okay. Yes, Angelina. So guys, whenever I solve this equation for C, what do I get? Ooh, I don't want. What did y'all get when y'all solve that equation for C?
I got 5.75.
Try that again.
Knew it.
Stephanie, 51.1298, that's C squared. That is not C. Right, so Stephanie, you said that 51 point,
I
0.1.
meant to say 7.1.
I'm sorry?
I got 7.15.
Yes. Mhm.
Oh shoot! I squared the wrong number.
You're fine. You just take the square of 51. Jeremiah, does that make sense now?
Yeah, I accidentally squared 5.66 for some reason.
You're
I
fine.
meant to do 7.07.
Stephanie, I hear some kids in the background. Your little siblings are around?
Yes.
They're playing as usual?
Yes, it's my little brother. He's 3. He's playing with my other one.
Oh, okay.
That's 8.
Okay, I got 7.15.
Yep, that's right.
All right.
Okay, guys, we're almost done with situation B. Okay, so we got 7.19 newtons. We got 7.19 newtons for the sum of our forces. So for situation B, we got the sum of our forces is equal to 7.15 newtons. Because when we did those steps, that's, in other words, guys, that is our net force. Our net force is 7.15 newtons. When I take this force and combine it with this force, I get 7.15 newtons. Last thing, guys, how do I find acceleration? I know the sum of the forces. How do I find acceleration?
You got to divide it by the mass.
Mm-hmm.
The mass is 5 kgs, or is that?
Yeah.
Okay.
The mass in every situation is 5 kilograms. So what did y'all get for that one? Y'all did it.
1.43.
Yep.
Oh, thank God.
And remember, meters per second squared. You always put your units for some reason. Okay. So guys, I just did the first two with you guys. So here's the answer to A is 2.33 meters per second squared. The answer to B is 1.43 meters per second squared. Any questions on A or B?
Sir.
And again, guys, this video will be on YouTube, so y'all can go back and look over it. This page right here, Stephanie?
Yes.
All right. So guys, understand these 3 steps are how you find your net force. Once you find your net force, which is in other words, when you combine both your vectors, then you just divide it by the mass to get your acceleration. Okay. Guys, before I let y'all go, let me say a few things. Some of these problems on here are easier than you think. So for example, guys, look at situation C. Look at situation C. Hold on, let me erase some of this stuff so I can. Hopefully y'all got this written down because I'm about to erase this. Okay. For example, guys, look at situation C. Remember, in the first step says to basically find your x and y components to your vectors. But guys, look at this situation right here. If you notice, we don't have to use trigonometry to label our x and y components. We don't have to do that because, guys, look at this vector right here. This vector right here.
They're both not diagonal.
Yeah, they're both not. Yeah, exactly. They're not diagonal vectors. So in other
They're
words,
both
this vector right here, this is -10, 0. Right? And then this vector right here is what?
6, 0.
Yeah, positive 6, 0. Okay.
So you just gotta add them together.
Exactly. So when you add those together, what do you get?
-4 and 0.
Yeah.
Then you gotta do the Pythagorean theorem.
Yeah. Well, check this out. We don't even have to do that because look,
Mhm.
my only vector there is just -4, 0. So in other words, what is the length of what is the magnitude of the vector? It's just the magnitude is just what?
-4 and 0.
Yeah, the magnitude is just 4.
Oh,
Yeah. So
okay.
remember what magnitude is. Magnitude just refers to how long the force is. So here, this is just 4. This force is 4 newtons. So basically, if you just take 4 divided by your mass, you're going to get the magnitude of your acceleration.
And that's 5.
Yeah, the mass in every situation is 5 kilograms. Yep. Okay, does that make sense, guys? Yeah. So here, the magnitude of your force is just 4 newtons.
Yeah, I got 0.8.
Okay, don't yell out the answer. I want everybody to know on their own. But thank
Okay.
you,
I don't know if my answer is right, y'all. Wink, wink.
though.
So
Okay.
y'all should really double check and do the work yourselves.
Okay. One more thing I want to say before I let you guys go, because obviously you guys can do the rest by yourself. Guys, normally in the past, what I would have my students do, I would have my students not only to find the acceleration, but I would also have my students to draw out the direction of the resultant force. Now, I'm not going to make you guys draw any directions because, again, we're not working in the classroom, and I haven't given you guys any graphing paper because normally what I would do during a normal school year, I would give all of my students graphing paper and they would show me the direction of the resultant force. But since we don't have any graphing paper, since I don't have any graphic paper to hand out to you guys in person, I'm just going to show you guys real quickly, guys. If you go back to situation A, whenever you combine these two force vectors right here, what will the resultant vector look like? Well, remember the resultant vector is going to be 10.19 pointed to the right and then 5.166 pointed up. So it would look something like this. So guys, let's draw that out. So 10.19 looks something like this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. No, hold on. That's too much. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wait a minute. So guys, 10.19 looks something like that. And then 5.66 looks something like this. Okay, so notice 10.19 in that direction, and then 5.16 pointed up. So this resultant vector is going to point like this. So guys, look at that arrow in blue. Y'all see the arrow in blue? What that's telling me, if I take these forces right here, and I pull on this treasure chest with both these forces, this treasure chest is going to accelerate in that direction. Does that make sense? That's what that arrow means. That arrow tells me how the object is going to accelerate, because we're basically combining both these vectors to get a single force vector that's look like this. Does that make sense, guys? And again, y'all don't have to draw that. I'm just explaining it to you guys. Guys, what about in situation B? So this is situation A. In situation B, notice in situation B, I have two forces acting on my object in situation B. All right, so I have one force pulling like this, and I have another force pulling like this. Guys, if I were to combine both those forces together, where would my treasure chest accelerate? In what direction? Well, let's see. Remember, guys, whenever we combine both these force vectors, this is what we got. We got a force vector that was pointed at 1.07 units to the left and then 7.07 units up. So I'm gonna draw that out. I'm gonna draw that out right here. So 1.07 looks something like this. 1.07 to the left looks something like this. And then 7 units up would be something like this. 1, 2, 3, 4, 5, 6, 7. Okay. So if I have to draw my resultant vector, remember I would just connect my points. It will look something like this. So guys, look at that arrow in blue. Hopefully, guys, it should be obvious to y'all. Guys, if I take this treasure chest and show you that I'm pulling with one force acting in that direction and another force acting in that direction, if both those forces are acting simultaneously, then the resultant object is going to move along the direction of the blue arrow. It's going to move up and to the left diagonally like that. Does that make sense, guys? So that's why I say it's important that you get your direction right, because like basically your direction tells you how the object is going to move. Now again, guys, for your assignment, you don't have to worry about drawing the vectors. My big thing, as long as you can tell me the magnitude of the acceleration for each situation, you're going to be good. Of course, I want to see the steps that you take: step 1, step 2, step 3, and then find me the magnitude of the acceleration, and then that's pretty much it. Okay. Any questions? Any final questions?
No, sir.
Okay. Guys, I'm going to keep the Zoom call open up for another 20 minutes in case you guys have any questions for me. For those of you guys that did not have the opportunity to get the attendance form, I'm going to put the attendance form in the chat box again. Oh, thank you, Angela. You beat me to it. Guys, the attendance form is in the chat box. Please click on that and get that filled out. Again, as soon as you guys get done with your work, just take a picture of it. Please circle your acceleration so that I know what you guys get for the max of your acceleration. And you guys are free to go. I'm going to keep the Zoom call open up to 3:20 for anybody that has any questions for me. Have a good one, everyone. Bye, guys.
You too. Have a good day.
Stephanie said, told me to have a happy Valentine's Day. Stephanie, I'm single, so Valentine's Day doesn't mean anything to me.
You can
could
go
find
on a date
somebody.
with yourself.
I can't find someone that fast.
Oh yeah, she's not a teenager like us.